This huge IBM Model 57 is a super fast 386-based PS2 system. Thanks to 8K of level 1 cache, this IBM outperforms any regular 386, even before we did any upgrades. Last week we restored this IBM and repaired the matching SLC2 interposer. With the interposer installed, it's now clock double to 40 MHz and has 486 instructions and 16K of level 1 cache. This thing is flying now, but we always want more, don't we? So in this video we're going to see if it can be overclocked. We are also going to install Windows and a CD-ROM drive in that large gaping hole in the front. Okay, that was enough for the intro. Let's get started. I took the motherboard out off camera, since we made a complete disassembly in the restoration video. And if you want to watch the restoration video too, I will put a link at the end of this video. So, unlike the interposer in the Model 5486, this interposer doesn't have its own crystal, so that means it must be getting its clock from the motherboard. According to Ardent, it should be this part here, but this is not the usual form factor that we are used to. But luckily I have ordered a couple of these for another project, so we can just borrow one of these. So one of them is a 40 MHz, and that's actually exactly what we have on the motherboard, so that's useless. But this guy here is running at 46.1 MHz, so that should be good enough for our test. I'll start by adding some fresh solder to all the 4 pads to make it easier to remove. The pads on this side are a bit hard to reach, but not impossible. I'll just place a big blob of 6040 solder, and then I'll use the Rework station, being careful not to melt this connector here. I'm not having much luck here, so I think one of the pins is connected to a large ground plane that is sucking up all the heat. Well, in that case, let's add some chip quick to keep that solder molten for longer. I guess we could preheat the entire board, but if this works, it's much quicker. I'll just add a big blob to each leg, and we'll try again. So this stuff melts very quickly and it stays molten for much longer. Wow, what a stubborn component. No, it's not coming off. Wow, what a stubborn little guy. Well, in that case, I'll heat the entire board up to 130 degrees Celsius. I'm sure it would eventually come off without preheating the board, but I don't like to apply too much heat in just one small spot on the PCB, because then the board tends to get bent and skewed. Not a big issue, but if I can avoid it, I will. And it's actually still really stubborn, so that ground plane must be enormous inside the PCB. I was expecting this chip to pop right off, but it still took some time. But now it's finally off the board. While the board is still toasty, I'll remove the chip quick and old solder from the motherboard. Oh, I see. This board actually also has through holes for a regular crystal. So maybe we won't need those weird ones. That is excellent. This means I have a lot more crystals to choose from. I'll clean the rest up with some Flux and good old wick. When using chip quick, it's really important to clean the board and make sure none of that stuff is left. Since it has a lower melting point, it shouldn't be mixed with a regular solder. I changed the preheater to 50 degrees and I'll let the board cool down slowly. But let's clean this Flux up while it's still warm and easy to remove. I better check those through holes while the board is still warm, because it's so much easier to work with on the preheater compared to when it gets cold again. When installing crystals on the motherboard, I used to use regular machine sockets and then just snipped the unused legs off. But when we did the P70 project, I noticed that the crystal was barely sitting in the socket and would quite easily fall out. But there seems to be some variations, because in this case here it actually sits quite firmly. But since it failed in the P70 projects, I used a regular socket instead and just pulled the unused pins off. And that worked really well. And it definitely does with this crystal too. But someone left a comment that I should try out proper sockets intended for crystals. So I picked this one up from Mauser. Well, let's see if there's a difference. No, not really. This is just a regular machine socket with unused pins removed. I couldn't really tell the difference between the proper socket and a regular machine socket. So this is probably just a regular machine socket with 4 of the pins removed. With the crystal we're going to try out now, it doesn't really seem to matter. So I'm going to keep the socket and we'll try it out with the crystal that doesn't sit this firmly in a regular machine socket. And here's another crystal. Yeah, this one sits really firmly in the fancy socket too. So how about a regular machine socket? Oh, there's actually a difference. It's actually not as tight. Yeah, there's definitely a difference. So maybe these sockets actually have slightly smaller holes. Yeah, definitely a difference. At least if I compare this socket to the regular machine socket I have. And this is a cheap socket from eBay, so perhaps it's made with lesser precision than the proper socket here. I think I'm gonna put this guy aside and we'll try it out with different crystals in future videos, because I want to know if it actually is better than a regular socket. So for this board we're just gonna go with regular socket, and I'm going to remove the unused pins, since it doesn't seem to matter with the crystal that we're going to use today. Okay, minding the notch. Let's just install this guy. This board is so crammed on this side. It's kind of hard to find the right through holes. Okay, that's done. And this board now has a socket for crystals. Instead of the 40 MHz crystal, I found this 50 MHz crystal in one of my other machines. Now let's hope all the components on this board will do 50. Okay, motherboard reinstalled. We'll do the first test without the interposer installed. And we'll see if that SLC on the motherboard will do 25. Okay, fingers crossed. Let's see if this works. Oh, we've got a cursor. So at least it's doing something. Come on, little PS2. You can do this. It's reading the diskette. Oh, and it's posting. Awesome. Okay, let's hope it's stable. We still only have 8 megs of RAM on this board, so we need to install some more. And we've got the usual battery error because we removed the battery, so that's perfectly normal. We should get another error because we have removed the interposer. Wow, this might actually work. Keep your fingers crossed. And here's that processor board error that we expected. And it's complaining about time and date. I'll just set random time and date here. Automatic configuration is being run. And it's done. So let's reboot. Okay, no more errors. Sweet! So let's see if this machine boots. And it does. Awesome. Okay, let's run SpeedSys. See what it thinks about our shenanigans. Okay. It thinks we have a 386DX running at 26 MHz. Not quite right, but not too far off either. The microphone probably picks up quite a lot of noise from the hard drive, but in real life here, that drive actually sounds pretty good. Okay, and we've got a score of 6.68, and here's our 8K of cache. So everything seems to be working. So let's see if it's stable, and run Superscape 1.0C for faster PCs. We got a score of 13.1. That is a pretty decent score for 386. Let me check what we got with the original crystal. And with the original crystal, we got 10.4. So that is roughly 30% speed increase just by swapping the crystal on the motherboard. So if you have one of these, you definitely need to replace that crystal. But that's not what we came for, is it? So let's install the SLC too. Several viewers left a comment in the restoration video that I should have straightened up the pins, but unfortunately several of the pins were broken off and missing. So although it probably could have been repaired, it just doesn't make any sense because this socket here was so easy to make. But I agree, it probably would have worked. And I have successfully soldered the missing pin to 486 once. So it can be done. Okay, the moment of truth. Will the 57 do 50 MHz? Oh, we got the cursor. And it posts. Keep your fingers crossed. And I have a couple of errors, just as expected. And now I get that same processor board error, because we have installed the interposer. Automatic configuration being run. And complete. Let's go to set features. That's strange. I removed the riser when I installed the interposer, but it still remembers time and date. So apparently the battery can be removed at least for half a minute without losing the time and date. Okay, now to the real test. Let's see if it boots. And it does! Awesome! So this 20 MHz 386 is now running at 50 MHz and has 486 instructions. That is a hell of an upgrade. Okay, let's check with SpeedSys and see what it thinks about our upgrades. That is awesome. So it recognizes the system as a 486SX running at 50 MHz. I've had some varying results with the score in this benchmark here, so I more or less ignore SpeedSys benchmarks. As you can see on the scale, it's probably more designed for much faster systems. And we've got our 16K of level 1 cache. Now let's try Superscape 3D Bench. Okay, and we had 16.5 with the original crystal. And we passed 20.6 FPS. Wow, this PS2 is a real overclocker. So from 10.4 to 20.6. So we have pretty much doubled the FPS on this system. With a messed up interposer, probably from e-waste, and a very cheap crystal from eBay. I'd call that a success. Well, 50 is plenty fast, but I want to know where the limit is. Unfortunately, I don't have any crystals between 50 and 60. And even my 60 MHz crystals are in the wrong form factor. So we need to bodge this sucker to fit. Oh, by the way, if you're all new to this, the board divides down and runs the CPU at half the speed of the crystal on the motherboard. So that is why the original SLC was running at 25 MHz. But the interposer has a clock multiplier, so it doubles the speed back up to 50. So that's why the SLC2 ran at 50. So I'm going to solder these wires to a socket, and then I'm going to install this crystal in the socket. It's a bit tight, but I think this will work. So I'm going to solder the two wires to the legs of the crystal, like so. And now we can snip the rest of these wires off. So this is what I'm thinking. These leads here are going to end up in the correct pin, and these pins here are going to connect to the motherboard with this pin here. So this should basically be working like the smaller crystal. Okay, let's see if there's room enough for this contraption. And I think it is. Okay, fingers crossed. Let's see if this works. Oh, we got a cursor. Oh no! And an error, 103. So what the heck is a 103? I guess that's the error for taking things too far. Let me check. Apparently it's basic ROMs checksum error. But for the model 90 and 95, this is a processor board error. So I guess we should do quick tests without the interposer. Oh, I just realized we didn't have the battery installed. So let's just make sure that we didn't get that error, because the riser with the battery was removed. Here goes. And we got a cursor and that same error. Okay, so we know it won't run at 30 MHz. Okay, next up we have the RAM. This board has two 4 meg modules and one 8 meg module. And we had some issues and errors when installing the 8 meg module. So I checked the part numbers, and this stick should be compatible with this board. So I ran some tests, and unfortunately that is a faulty module. So 4 megs of memory has been turned off. Have your system unit serviced? I guess I should call IBM. Well, long story short, I did some troubleshooting with the RAM. I found another 8 meg stick, but I got the same error. So then I moved these RAM sticks around and tried different combinations. But in all combinations I got that same error. So then I ran update system programs, and that totally fixed the problem. I don't get that error anymore. And now we've got 16 megs of RAM. Well, actually 14.9. Not sure what that is all about, but that's good enough for me. If you know why we're getting slightly less RAM here, then let us all know. But I'm gonna say this problem is fixed. So we now have 16 megs of RAM. And that's perfect for Windows. Before we make the next upgrade, I'm going to wipe that hard drive and install Windows, because I want to run some tests for comparison. So let's jump into FDisk and delete the primary partition, and then create a fresh partition. I don't have the matching PS2 drive for this machine, so this plain SCSI drive is going to have to do. This drive is untested, so I'm going to have to start with the tests. Okay, so at least it opens up, so it doesn't seem to suffer from sticky rubberized paint inside. Since we removed that partition, we need to run the reference disk. And interestingly enough, the RAM error is back. So I think I know what we need to do here. I think all the settings are stored on the hard drive on these machines. And then I think we need to update the system programs again. The files will be copied from the reference disk. Updating the system programs also requires this diagnostic diskette. I found a copy on Ardent. This update also requires power cycling the machine. And everything seems to be working. Now let's hope this SCSI CD-ROM driver works on PS2 systems. because I have never tried this driver on a PS2 before. And let's hope for the best. Oh crap, it doesn't work. So we need a different driver. I installed the drivers for the CD-ROM drive off camera, but I'll put enough information on the screen here in case you're installing a CD-ROM drive on one of these machines. I also installed Windows 95 off camera, because we're actually not going to run this OS on this machine. This is just for a quick test. Okay, so this machine only has regular VGA graphics. So we're stuck at 640, 480 at 16 colors. So let's do one more upgrade today. This is an IBM 8514A graphics card. And it will take us from 640 by 480 to 1024 by 768. Not necessary for DOS games, but very nice in Windows. This card also has the extra expansion card with a crap load of VRAM. And that is going to take the graphics from 16 colors to 256. This card has to be installed in this special slot here. This extra piece here is to pass through the VGA graphics to the 8514A card. And it won't work in these regular slots. With this card installed, we should get significantly improved graphics. Before we put the lid back on, let's install the CD-ROM drive. I looked through my stash, but I couldn't find any PS2 rails. So I grabbed a couple of these and cut a piece off at each end to make it work. Not a very elegant solution, but this is what I had in my stash. These are the rails that Adrian Black made when he restored his AT years ago. So they are easy to find online. And if you're stuck with your PS2 project too, then just cut both sides off and leave roughly 10 millimeters on each side from the screw hole. So if I measured correctly, this drive should now fit in this machine. Now we can put that bezel back in. And these tabs here are aligned with the rails. Should lock that drive in place and prevent it from falling out. Unfortunately, I think I cut too much from those rails. So cut slightly less. Or even better, make proper copies of the original PS2 rails. Now we can put that lid back on and see how it looks. Yeah, I cut slightly too much. Well, that looks pretty good and definitely much better than a large gaping hole. But it's actually not perfect because there is a gap around the drive. So I guess there must have been a special PS2 bezel that should be installed with the drive. It's not really noticeable from most angles, but if you look at the drive straight ahead, then you can clearly see these gaps. So slightly annoying, but not a major issue. I think I can live with this, but I guess a printed bezel would have been really nice to install here and make it perfect. As expected, the system gives us a 165. That basically means found new hardware in PS2 language. I have downloaded the ADF files for the 8514A card, and now these ADF files have been added to the system partition on the hard drive. If this is all new to you, ADF files are sort of like drivers for PS2s. Well, the graphics card is installed, but now we get that weird RAM error again. But by now we know how to fix it, so it's not a big issue. We're back in Windows 95. Now let's see if Windows 95 has drivers for this ancient card. The graphics are actually slightly worse in 640 by 480. So let's see if we have IBM in this list. No, it only has XGA and XGA2 drivers and a ThinkPad. Crap, so I need to find and download the drivers. Well, long story short, this driver was really difficult to find. It's probably available at Ardent, but I couldn't find it. But I did find this driver here on a sketchy web page. But it's for an 8514A compatible. So these are probably not original IBM drivers. But let's try them anyways. See what happens. They did work. So apparently that sketchy web page didn't supply me with a virus. And the graphics jumped up to 1024 by 768. and 256 colors. Let's apply and reboots. Oh no, something went wrong. I've got a black screen. Crap. And that turned out to be a combination of a compatibility issue and a driver issue. With the proper CRT, it does load. You can see the vastly improved graphics, but unfortunately the system froze. So I need to find the correct driver for this card and Windows 95. If it exists, I don't actually know if it does. Since I can't use the system, I can't change the refresh rate. So that's why you have this weird flickering. It doesn't sync with the camera. Okay, I think I may have found the problem here. 1024. This display runs at a really weird refresh rate at 43.5 Hz. So I need to go through my collection of CRTs and see if I can find a display that will handle this weird refresh rate. And back at 64480, the display works perfectly. Well, this IBM turned out to be a real overclocker, so that was fun, but we're not done yet. I'll check with the guys at Ardent and see if they can help me with proper drivers for that graphics card. And then I'll check my collection and see if I can find a CRT display. Not sure what's up with that screensaver. I don't remember it being this quick. But anyways, this machine also needs a sound card, obviously, so we can use it to play some DOS games. So if you're watching this in the future, there will be a link on the screen here to the next video. If you're watching this fresh, hit the bell icon below and set it to all. Meanwhile, check out this video. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. Thank you for watching. I'll see you next week.